Okay, so let's dive in and talk a little bit about this package called NumPy. So what we're going to want to be doing with NumPy is actually putting together what's called vectorized coding in Python. And that means we're going to represent things in terms of their linear algebra equivalent, right? So if we had two matrices or two vectors multiplied by each other, we actually want to represent that in Python using the exact same type of syntax that we would typically use with a pencil and paper. And the way that we do that is through a package called NumPy. Now, NumPy was created by Travis Oliphant. He's now one of the, he's the founder of many packages, including SciPy, which is a scientific computing, a numerical optimization toolbox for Python. He's also founded NumPy in 2005, and he started something called Numba in 2012, which is essentially a just-in-time compiler for Python to make it even faster when we're using for loops. Now, the way that you pronounce NumPy is NumPy. It's not NumPy, NumPy. And essentially, it's a wrapper written in Python to an underlying code base that's written in C++. Now, that C++ code base is really meant for doing all sorts of linear algebra operations and a number of other operations too that aren't related to linear algebra, but specifically numerical computing. That means it's a very fast language because under the hood it's written in C++, but it's also very expressive because the Python wrapper allows us to do a lot of different syntax and highlighting and numerical operations very efficiently and intuitively, while underneath the hood we're really calling C++ code. Now, NumPy is also an open source product. And that means a lot of good things. It means a lot of people can pick up NumPy and use it in their code base for whatever they want to do it with. And they can really write C++ wrappers and get down to the really high level or the low level memory management that's required to make things really quick. Now, what that means is that most scientific computing packages that you download for Python, they actually use NumPy under the hood, and because it's open source, they have access to all of that C++ code. They can write their own C++ code to make things very quick and efficient. So NumPy is actually used under the hood in almost every single scientific computing package. That includes things like SciPy, also written by Travis Oliphant, scikit-learn, pandas, scikit-image, OpenCV uses it, the Python package for OpenCV. They use NumPy as an interface to go between the matrices that they use and the matrices that you input in Python and the matrices that are used as part of the OpenCV mats. It's part of a plotting package called matplotlib. And it's really used under the hood for many. If you've ever heard of Dask, it's used under the hood for Dask. And so it's a really efficient way of incorporating these operations on numbers. Now, for data science, typically what we're interested in is table data. And more often than not, that's two-dimensional table data where we have a matrix of values, rows, and columns. Those rows and columns typically mean something to us. So for example, each row might be a separate observation, and each column might be some type of measurement that we're pulling from the environment. It could be sensor data, it could be text, it could be all sorts of different things, but we basically boil it down. At the end of the day, we turn it into a two-dimensional matrix with rows and columns, and that might be instances and the different features that we have represented for each column.